Naming covalent compounds. Remember, covalent compounds are also known as molecules. Since it's a different type of bonding than ionic compounds, the naming is going to be slightly different. In naming covalent compound, we use what are called prefixes. If you don't remember what a prefix is, it's the beginning part of a word that changes or modifies the word meaning. For example, the word repaint has the prefix re. Okay. Re means to do again. So if you repaint something, you paint it again. When we're talking about naming covalent compounds, however, the prefixes indicate the number of atoms in that compound. For one, the prefix is mono. 2, the prefix is di. 3 is tri. Some of these might be familiar because they are used in everyday terms, such as a tricycle. 4 is tetra. 5, penta. 6, hexa. That's an H, not an N. 7, hepta. 8, octa, like an octopus. 9, nona or nona. And 10 is deca. All right, so these are the prefixes that go with the different numbers. So what I'm going to show you next is a flowchart that will help you name these molecules. The first thing you have to look at is a subscript. If you're not sure what a subscript is, it's the little number. Okay, for example, if I have the molecule H2O, now I know you guys know what H2O is, but we're going to go ahead and give it the covalent compound name. Excuse me. So is there a subscript for the first element? So we look at the first element, and yes, it has a subscript of 2. So we follow this flowchart to yes, and this is our first set of instructions. Write the prefix associated with the subscript followed by the name of the element. So if you look back at your list, the the prefix for the subscript 2 is di. So I would have di. So I'll put it up here. And the name of the element is hydrogen. Then notice the arrow comes over here. Is there a subscript for the second element? There's no subscript here. Since there's no subscript, we write the word mono, followed by the name of the element. Remember, it ends in "ide," so it is similar to how we named the ionic compounds. So we write mono, and then oxygen, of course, becomes oxide. Since it already ends in O, I'm just going to add oxide. So dihydrogen monoxide. Okay. If you're wondering why we use the term mono, mono means 1. And remember, if there's no number there, we know it's a 1. Okay. Let's do a couple more examples. If I have CO2, another common compound that you guys are very familiar with, follow your flowchart that you should have copied down. Is there a subscript for the first element? No, there's no subscript here. So all you have to do is write the name of the element. Is there a subscript for the second element? In this case, yes. Write the prefix associated with that subscript, and then followed by the name of the element. Remember, it ends in "ide." So the subscript for 2 So the prefix for 2 is di, and we know oxygen becomes oxide. And that's all it is. If we were to go the other way, let's say I have di, carbon, octahydride. What we need to look for in the name is, do we have any prefixes? And yes, we have a prefix right there. So the first element is carbon, as it tells us right there. Carbon is C. Di means I have 2 carbons. Okay. Now I look at the second part. Octa is another prefix. Octa, I know, means 8. So now we just have to figure out what hydride is, and hopefully you guys can recognize that hydride would be hydrogen. So the formula for this compound, dicarbon octahydride, is going to be C2H8.